Hello, in this video we will go over the basic properties of probabilities. The properties are listed in this table over here. Property 1 states that the probability will be between 0 and 1. Probability of 0 is called an impossible event. The probability of 1 is called a certain event. The formula is equal to the number of ways an event can occur over the total number of possible outcomes. So we'll put this into practice by applying it to these two problems over here. It says in this first problem, which of the following numbers could not possibly be a probability? Justify your answer. And so basically we will use property 1, 2, and 3 to answer A, B, and C. If it satisfies one or more of the properties in this table, then it's a possibility. If it doesn't satisfy a single one, then no, it's not possible. So letter A, it says 0.462. We'll use the first property and see if it satisfies that. It says that the probability has to be between 0 and 1. And so we have to ask ourselves, is 0.462 between 0 and 1? The answer is yes, it is. So because it satisfies property 1, it is possible. So this is good. Letter B, notice here that we have a negative sign. So it's a negative 0.201. Let's use property number 1. The probability has to be between 0 and 1. Well, if it has to be between 0 and 1, and it can also be 0 and 1, but negative 0.201 is less than 0, then this falls out of the range. Therefore, it does not satisfy property 1, does not satisfy property 2, does not satisfy property number 3, and since it doesn't satisfy any one of these, this is not possible, and we can just simply state that it doesn't meet any of the properties, or doesn't let's see how we would say it, does not meet property 1, nor because it is a negative number. Yeah. And then C, it satisfies property number 3, which is fine. So it could be 1. In this next question over here, we have a table with rooms on one side and the number of units on the other side. It asks, a U.S. housing unit is selected at random. Find the probability that the U.S. housing obtained has, and then letter A says 4 rooms. And so we will be using this formula here, which is F over N, the number of ways an event can occur over the total number of possible outcomes. 4 rooms, we look at how many units have 4 rooms. And we see that it says 23,636. We would divide this number by the total number of possible outcomes. So it would be the summation of all these housing units. I went ahead and did the math, and I got 132,415. You can, add these numbers up and to confirm that this number is correct. And so it would be 23. Unfortunately, I can't. Let me see if I can write on here. It would be just a moment. Let me get this. So to answer A, it would be 23. So let me just write this nicely. It's asking for the probability equals 4. 4 rooms. And so that would be 23,636 over 132,415. Okay, that will give you a number, and that will be the probability for that. B asks for more than, so it's the probability greater than 4 rooms, which is going to be the summation of I'm not going to be able to type all of this, but maybe I will be. I don't know. Depends on my mood. 7, 7, 7, 9, 17.868 plus 19, 257. So it'll be the summation of these. And it will be over 132,415. Okay. So let me explain exactly why this answer is correct. You're looking for the probability that a housing unit will be greater than will have more than 4 rooms. Okay. And so the way we think about this is that the units that have more than four rooms are units that have 5, 6, 7, and 8 plus. We add only these numbers because these are the number of units. This is just the qualifier. All right. So the qualifier is that it has more than 4 rooms. 5 is more than 4. That's right. 6 is more than 4. That's good. 7 is more than 4. That's good. 8 plus is more than 4. So we only are concerned with these 1, 2, 3, 4 numbers divided by the total number of possible outcomes. Okay? And so that would be this answer here. Letter C says 1 or 2 rooms. Now, notice the verbiage here. It cannot say 1 and 2 rooms because that's kind of impossible. The room, it either has 1 room or it has 2 rooms. It can't have both. So, but the way we answer it is the same way that we did with the last problem. So it says it has to have either 1 or it has to have 2 rooms. What are the probability? What are the chances you will choose a unit that has 1 or 2 rooms? Okay, well, that's easy. We'll solve it right now. It is going to be 601. Okay, we get this number from the table here. 601 has 1 room plus the 1404. All right, over the total number of possible outcomes. Okay, let's go to letter D. It has fewer than 1 room. Okay, so we look at our chart. So we're looking for a housing unit that has 0 rooms, which is funny. I wouldn't want to live there. So because of that fact that there are no, so it's going to be less than 1. We are not given a number of that, so it's going to be 0. 0 over 132,415, which gives you 0. Okay. And last but not least, move that up there. It says 1 or more rooms. So it either has 1 room or it has more than 1 room. So more than 1 would be 2, 3, 4, 5, 6. So basically the whole thing. So since that is the case, equals 1 or P equals greater than 1. Okay, that would be 132,415 over 132,415, and that will give you an answer of 1. Okay, so the chances of you picking a housing unit that has 1 room or more than 1 room is 1. You will definitely choose a housing that either has one or more than one room. All right, and so that's how we use the basic properties of probability to solve questions like that. Thank you.